16B. 100 draws are made at random with replacement from the box. 1, 2. 47 draws turn out to be 1, and the remaining 53 are 2. How much is the sum? Oh, was that my phone? So, first off, do you think that the box is biased? No. If we were flipping coins and we got 47 heads and 53 tails, that's pretty close, right? So if we were to flip a coin 10 million times and you got 47 heads and 53 tails, would you think that the coin is biased? Probably. With that many flips. Yeah, and we'll come up with a formula on how to figure that out later. Okay. So now we are adding up the tickets of the box. So you're playing this game, somebody has a whole bunch of money they want to give away. You draw out a 1, they give you $1. You draw out a 2, you get $2. So if you drew 100 times and had 47 and 53, how much money did you make? Well, it would be 47 plus 53 times 2. So 47 and 106 ends up to be 153. Okay, now that is the sum of the draws. So the sum of the draws is 153. Okay, what is the average of the draws? It's not on the question. So what is the average of the draws? Well, how many draws did you make? 100. So 1.53. What does that mean? Each draw was worth $1.53. Does that make sense? I mean, why does that make sense? That's the average of the box. There's a 1 and a 2. The average of 1 and 2 is 1.5. So each draw from this box is worth $1.53. Okay, number 2. 100 draws are made at random with replacement from the box 1, 2. How small can the sum be? Not 1. 100. Right? If all you draw are 1s, then the sum would be 100. Is that very likely? No. Very, very unlikely. Okay. How large can the sum be? 200. So every possible 100 draw combination must land somewhere between 100 and 200, with the average being 150. How many times do you expect the ticket 1 to turn up? 50. And 2? 50. About how much do you expect the sum to be? 150. Why? Okay, so we have to be a little bit careful. So somewhere way over here is 200, and somewhere way over here is 100. So we would expect the center to be 150. Okay, now you do have to be a little bit careful because you can't always just take the average of the two. So, well, okay, hold on. Scratch that. Just wait and see. But here's what I would do. In the box, we have a 1 and a 2. The average of the box is 1.5. And we're going to do 100 draws, which is 150. Right? We could find this number without using these at all. And it turns out that this is not always in the middle of the high and the low. For instance, what if my box was 1, 8, 9? What's the high? 900. What's the low? 100. Is the average going to be right in the middle of 100 and 900? No, because of the 8 is pushed way to the right. So instead, we would do 1 plus 8 plus 9 divided by 3, whatever that is, times it by 100. So that's 18 over 3 is 6. So the average is 600. Is 600 right in the middle of 100 and 900? No, it's pushed to the right. Okay? So you can't always take the average of the high and the low, but you can always find the average of the box and then multiply it by the number of draws. All right. 4. 100 draws will be made at random with replacement from one of the following boxes. Your job is to guess what the sum will be, and you win $1 if you are right to within 10. In each case, what would you guess? So for box 1, what would your guess be? So 1 plus 9 is 10 divided by 2 is 5. 5 times 100 would be 500. Right? Okay, and then for box 2, what's the average going to be? 500 again. That's 5 times 100. And then box 3, 500. Okay, now, which box would you use and why? Why? So for box 1, we're going to be anywhere from 100 to 900 with an average of 500. For box 2, we're going to be anywhere from 400 to 600 with an average of 500. Which of those two boxes are better? The second one. Why? The gap isn't as big, which means each individual column is a larger portion of the whole. Over here, this 500 is so narrow compared to the whole graph that it would be extremely unlikely. Well, not extremely unlikely, but much less likely. Okay? So for the other one, what's the high or the low? 500. What's the high? 500. What's the average? 500. What does that mean? You win every time. Okay? It's like saying, I've got a basket with a rubber ball in it that's red. You're going to draw 100 times. Actually, 2 rubber balls that are red. You're going to draw 100 times. If you can get a red rubber ball 100 times, you win. Okay. Is the second rubber ball even needed? No. We could just say there's 1 in there. Or there could be 10. It doesn't matter. But we like to simplify the boxes if possible. What's that? Yep, you're a winner. Number 7. You gamble 4 times at a casino. Shame on you. Haven't I taught you anything? We don't gamble at casinos. Okay. I did gamble one time in Las Vegas. I was down there with my little brother, and he was like 17, and he gave me $2. We were at one of the cheap casinos in the old part of Vegas on Fremont Street, and he said, "Here's $2. Put it on red." So I did, and it was his money, and it came up black, and he lost. And he said, "Oh well." So, but it wasn't my money. That's true. So you win $4 on the first play, you lose 2 on the second, win 5 on the third, lose 3 on the fourth. Which of the following calculations tells you how much you came out ahead? So number 1, 4 plus 5, that would be the total winnings, minus 2 plus 3 would be the total losings. Now those are in a different order, but it doesn't matter. So that one takes the winnings and subtracts the losings, the losses. Okay, will number 2 work? So $4, and that ends up being minus 2 plus 5 minus 3. That works. Will number 3 work? No, what's wrong with it? The 2 is positive, it needs to be negative. And then number 4, it's all sorts of messed up, right? There are lots of things wrong. In fact, the only thing that's right is the 5. Everything else is wrong. Okay.